For number 60, this is great evidence that you don't need to have all these high school classes to be able to get these seemingly hard questions correct. So the only thing that they are testing in this question is that you know one concept about multiplying matrices. And that concept is that in order to multiply two matrices, the number of columns in the first matrix must equal the number of rows in the second. So go ahead and add that to your cheat sheet, master that, and go back 5 before continuing in this lesson. But that's all you need to know. And so now go ahead and try to solve this question with that information. You can pause the video and I'll explain it in just a second. So we'll go through each of these and we're just going to check if the number of columns in the first matrix is equal to the number of rows in the second. So for answer F, we're multiplying E times D. So the number of columns in E is M, and the number of rows in D is M. So this one is possible, which means it's not our answer because we're trying to find the one that we cannot multiply. All right, G. So we're doing D times C. So D is our first matrix, which is going to be K for our number of columns in our first matrix, and times C, the number of rows is also K. So we can go in and eliminate that one because we can multiply it and we're looking for the ones that we can't. For H, the number of columns in C is N, and the number of rows in E is N. So those are the same. We can multiply them, so that's not our correct answer because we're looking for the one we can't. For J, it's A times E. So the number of columns in A is N, and the number of rows in E is N. So we can multiply that, leaving us with just K. So this is certainly going to be our answer, but we'll just check it. For A, our number of columns is N, and for C, our number of rows is K. So we cannot multiply this because the number of columns in the first does not equal the number of rows in the second, and we are done.